This slideshow is going to be a review of the models of how particles behave in different states of matter. In this slide, we are viewing how the particles of a solid are organized. Notice how the particles are all connected and are all tightly packed together. In this slide, the particles appear to be still. However, it is really important to note that particles are actually moving. They are just vibrating in place. Much like when you're sitting at your desk, you can move your hands, your feet, your head, but you should not be moving around the classroom. In this slide, we're looking at an image of the particles in a liquid. You should notice that the particles are not as organized and are not as tightly packed together as particles in the solid. The particles are still connected, but they can slip and slide past each other. Particles in a liquid have more energy than particles in a solid, and they move faster. An example of this would be when you are leaving the classroom and other students are coming into the classroom. You're slipping and sliding past each other in the doorway. In the online simulation, I'm going to first mark two particles. Here's a particle here, here's a particle here. This is how particles in a liquid move. Notice that they have energy and that these particles are actually exchanging places, moving past one another. Now they're close to each other. So these particles can move around the sample. They can even end up at the top right-hand corner, the top left-hand corner. In this slide, we're looking at how the structure and how the movement of particles behave in a gas. Notice how the particles are spaced far apart from each other. The particles in the gas have much more energy than the particles of a solid or a liquid. Particles are not connected to each other. Also, the particles have no structure and they can move around randomly. I will take you through another online simulation where I'm going to mark two atoms and I'm going to go ahead and show how these are moving around. Notice how they are moving at a random pace. Now I want you to look carefully what happens to the movement of the marked molecules when they strike another particle. Notice that when a marked particle hits another particle, the marked particle will transfer its energy and slow down. Notice too how when another particle hits a marked particle, the marked particle will then speed up. The marked particle got energy from the particle that hit it. So energy is being transferred all the time. In this slide, we see the models of the particles in the different states. The first image right here is the model of a solid. In this the middle image is a model of a liquid. And this image over here is a model of a gas. In the future, when drawing models of particles in a substance, I want you to make sure that you are drawing a solid. The particles are tightly packed together and organized, that the particles have a structure and that they move very slightly. Models of particles in a liquid should show much less structure and a little more space between the molecules and a little bit more movement too. Particles in a liquid will also have more energy and move faster than a solid. Particles in a gas are going to be farther spaced apart and have a lot more energy. Unlike the other drawings that did not have the whooshies in it, I thought I'd show you what a drawing or a model of a liquid should look like. Notice that the particles are spread farther apart, but they're still kind of close together. These are the whooshies that I talked about. They show that there is movement. If you have a solid, you want to make sure that you're doing one whooshy. If you have a liquid, you might do two whooshies. And if you have a gas, you might do three whooshies. In a solid, though, it's going to be kind of difficult to put these on each and every one. So sometimes we just put one whooshy going around to show that there is some sort of energy there. If we mention mass of a particle or mass of a substance, when we draw our models, the closer together that these particles are, shows the more mass. That's because more matter is crammed into a tighter space. In this slide, we have some links to some videos that will help you better understand the concepts that we're talking about here. To access them, open up the particle model slideshow that's in your Google Classroom and click on the links. If the links don't work, you may have to sign into your own personal Google account and then search for the Eureka videos. I want to talk a little bit here about kinetic energy. Kinetic energy is the energy of motion. Remember that particles in all states of matter, solids, liquids, gases, are moving and have kinetic energy. Different states of matter will have different amounts of energy. Which state of matter do you think has the most kinetic energy? Gas.